In this class, we're going to go over chi-squared. We're going to learn how to test for the goodness of fit in chi-squared. Okay, let's start with the first example. A die is tossed 120 times with the following results. You can see the results. We are asked to test the hypothesis that the die is unbiased. You can see that this type of question is goodness of fit test because we didn't have a contingency table. You understand? Okay, so if you want to test whether the die is unbiased or it is biased, the first step is that we have to prepare our table. You understand? Don't forget that in our previous class I told you chi-square is given by this formula. Calculated chi-square is equals to summation observed minus expected squared all over expected. You understand? This is the formula for chi-squared. You understand? The calculated chi-squared. Now, in the question we are given that the tabulated chi-squared is 11.07. 11.07. Let me write it here. 11 points. That is the critical value 11.07. I'm going to show you how they got this value using the table. You understand? Because in some question you might not be given this value. You will be asked to determine the value by yourself through the table. You understand? There is a table whereby you are going to get this. Okay, so let's proceed. We have to prepare our table. You understand? So the table contains observed and the expected value. In the question we've been given the observed value, we have the numbers of phase turned up and we have the frequency respectively. You understand? So let's start. So I've already prepared the table. You see, the numbers of turn up is also the same thing as the numbers of phase. You understand? The phase number in a die is what? We have 6 phases. We have 1, 2, 3, 4, 5, 6. You understand? So don't be confused. The numbers of turn up is also the same thing as the numbers of phase that we have in a die. Okay? Now we are told that this die is tossed how many times? 120 times. That means that the total numbers of frequency that we must have must be equal to what? 120. So here I'm going to have 120. 120. Okay? Because the die is tossed how many times? It is tossed 120 times. So the total numbers of frequency, all this must be equal to what? 120. Okay, so we have been given the observed value. The observed value are the frequency that we are given. Okay, the observed value are the frequencies that we are given. We are given for phase 1. Okay, I think I must have another table. Okay, let me call it phase. Okay, phase. We have the observed value, we have the expected, we have the observed minus expected, we have the observed minus expected squared. Please pay attention. This formula will tell me what I'm going to have on this table. You understand? In this formula, I need the observed value. Okay, we need the observed value. The observed value are the frequencies that were given. You understand? The frequency that we are given in the question is the observed value. Now, I'm going to determine the expected value. Don't worry, I'm going to teach you, okay? Now, from this formula, I still need what? Observed minus expected. That's why I have this. From this formula, I still need the square of the differences between the expected and the observed value. So I have this. Now, I have to create another column. I need another column. So, I'm going to have additional one here. Okay, so here we stand for observed minus expected squared all over expected. You understand? Because according to this formula, I need the summation of this to get the calculated chi-squared. Do you understand? So this formula tells me what I'm going to have on this table. Okay, so now the phases are what? Phase 1, 2, 3, 4, 5, 6. You understand? You might not include the phase on your table. You understand? But I just want you to understand. That's why I include it. Okay. So the observed value for phase 1 is what? Is 30. The observed value for phase 2 is what? 25. The observed value for phase 3 is what? 18. For phase 4 we have 10. For phase 5 we have 22. For phase 6 we have 15. Okay. Now, what of the expected? How do we determine the expected? Now, please pay attention. Don't forget that the test we are dealing with is what? The goodness of fit test. We are asked to test if the die is unbiased. If the die is unbiased, the numbers of faces shown must be equal. You understand? When the die is stones, are you paying attention? If the die is stones, the numbers of faces shown must be equal for all the observed value. So, in an attempt to determine the expected value, you just have to take the total numbers of frequency that you have, which is what? 120, and divide it by the numbers of faces in a die. Listen to the explanation again. Okay? Listen. You see, if there is no bias, you understand? If the die is unbiased, if you throw the die 120 times, the numbers of faces shown must be equal for all the numbers of observed value must be equal for all the faces. You understand? That is, the expected value will be 120 all over the numbers of faces. That means that will be equal to what? 20. That is, 1 must appear 20 times. So, the observed value must be equal. That is 20. If you didn't understand, listen to the explanation again. If the die is unbiased, the die is thrown 120 times. That means that for all the faces, we must have 20. You understand? And how do I got 20? I divide 120 by 6 because the numbers of faces in the die is what? Is 6. You understand? So here I have 20. So that means that if we throw the die 120 times, that means 1 must appear 20 times if the die is unbiased. 2 must appear 20 times. 3 must appear 20 times. 4 must appear 20 times. 5 must appear 20 times. And 6 must appear as well 20 times. So the summation of this must be equal to what? 120. You understand? But from the observed value, please listen, okay? This is the observed value, this is the expected value. I'm very sure you understand now. Now, let's take the differences. Okay, let's remove this so that we will not get confused. Let's remove this. Okay, so now observed minus expected. That means for this I'm going to have 30 minus 20. Observed minus expected. 30 minus 20, that is 10. Okay, 25 minus 20, that is 5. So here I'm going to have 5. 18 minus 20, that is negative 2. 10 minus 20, that is negative 10. 22 minus 20, that is 2. Okay, 15 minus 20, that is negative 5. Okay, so here I'm going to have negative 5. Do you understand? Okay, now we need the square of the differences between the observed and the expected. You understand? So I'm going to square all these values. 10 squared is what? 100. 5 squared is what? 25. Negative 2 squared is what? 4. Negative 10 squared is what? 100. 2 squared is what? 4. Negative 5 squared is what? 25. Do you understand? Okay, so having gotten the square of the difference between the observed and the expected value, we need to divide all this value by the expected value. You understand? Okay, we need to divide all this value by the expected value. Now let's start with these cells. 100 divided by what? That is the 100 divided by 20. Okay, because the corresponding expected value for 100 is what? 20. Even though all the expected value are the same for all the faces, the expected value are the same because if the die is unbiased, the faces must show at equal numbers. You understand? Equal numbers of time. Okay, so that's why I have 20 here. So 100 divided by 20 is what? That is 5. Okay, are you paying attention? Now that will be 25 divided by 20. 25 divided by 20 is what? 1.5. 4 divided by 20, that will be 0.2. Okay, now 100 divided by 20, that is what? 5. 4 divided by 20, that is what? 0.2. Okay, 25 divided by 20, that is what? 1.5. Okay, 1.25. 1.25. I just hope maybe there is no mistake here. 1.25. Please, let me check. I want to check this. 25 divided by 20. Okay, it is 1.25. Sorry, this should be 1.25 as well. 1.25. Okay, 25 divided by 20 is 1.25. 25 divided by 20 is 1.25. Please, do you understand? Don't make mistake. Okay, if you are dealing with this in exam hall and you you get to a point maybe you are confused, just make use of a calculator. Okay, now remember that the formula for chi-squared is what? Summation observed minus expected squared all by expected squared. So we need to sum all these values together. Okay, so I'm going to have 5 plus 1.25 plus 0.2 plus 5 plus 0.2 plus 1.25. That will be 12.9. So here I'm going to have 12.9. Hence, the calculated chi-squared is equals to 12.9. Okay, now we've been given in the question that the critical value at 5%, the critical value at 5% is what? Is 11.07. Okay, so the critical value, that is the tabulated chi-square. Please pay attention. The tabulated chi-square is also known as the critical value. You understand? That is the chi-square that we got from the table. That is the critical value, or the tabulated chi-square. Do you understand? Okay, so here the tabulated chi-square, which is xt squared, is equals to 11.07. Don't worry, I'm going to show you how to get this on your table. Okay, so don't forget that xt at 5%. 5% is also the same thing as 0.05. It's what? 11.07. Okay, so the critical value is here. I mean, these are the critical value that we have. Now, how do we know maybe the die is unbiased or it is biased? How do we know if the die is unbiased or it is biased? See, if the calculated value of chi-squared is greater than the tabulated value of chi-squared, the hypothesis that the die is unbiased is rejected at 5%, at 5% level of significance. I'm going to explain. Okay, you see, in this you can see that the calculated chi-squared is greater than the tabulated chi-squared. This calculated chi-squared is greater than this. That means that the hypothesis that the die is unbiased will be rejected. You understand? And the reason is because the calculated chi-squared, that is xc squared, is greater than xt squared at 5% level of significance. So we are going to reject the hypothesis. The die is biased. You understand? The die is biased. The die is unbiased. If the die is unbiased, we are going to accept the alternative hypothesis. We are going to reject the known hypothesis. Now, the die is biased, so we are going to reject the known hypothesis and accept the alternative hypothesis because the die is biased. And how do we know that the die is biased? We knew because the calculated chi-squared is greater than the tabulated chi-squared. Let's say that the tabulated chi-squared is greater than the calculated chi-squared. That implies that the die is unbiased, so we're going to accept it. But because the calculated chi-squared is greater than the tabulated chi-squared, so we are going to reject the hypothesis. Don't forget that we are testing for hypothesis. That in the question we are asked to test for the hypothesis, maybe the die is unbiased. So in this case, we're going to reject the null hypothesis. Null hypothesis means that the die is biased. You understand? Please, all these are very simple. Okay, all you have to do is just to pay attention to the explanation. Okay, now I want to explain to you how to get the critical value. You know, in some cases you might not be given the critical value in the exam. Okay, so it is important that you learn how to use the table to find the value. To get the critical value using the table, you have to know the degree of freedom. Now, because we are not dealing with contingency table, in our previous class we have learned about contingency table. You can check the description of this video to watch other classes, the previous classes. Okay, so the degree of freedom for this chi-square is n minus 1. N is the numbers of rows that we have. You understand? Hello? The numbers of rows that we have on our table will be n. Okay? And we have how many rows? We are having 1, 2, 3, 4, 5, 6. We are having 6 rows. So here the degree of freedom will be what? 6 minus 1, which is what? 5. So the degree of freedom is what? 5. Now, the critical value that we are given, please just pay attention, okay? The critical value that we are given, is at 5% level of the 5% level of significance and 5 degree of freedom. Now let's go back to our table. Here we have our critical values of the chi-square distribution with the degree of freedom. You understand? This is how a typical chi-square distribution table looks like. Okay, on these chi-square distribution tables we have the degree of freedom which ranges from 1 to 20. You understand? Okay, now how do we use this table to determine the critical values? Perhaps if you are not given an exam. Now, to use this critical value table to determine the critical value, all you have to do is that you first have to identify your degree of freedom. Don't forget that while I'm solving the question, the degree of freedom is what? Is 5. You understand? Okay. Also, I want to take note of something. You know that when I'm solving the question, the degree of freedom, the formula is what? N minus 1. Now, n is the numbers of sample. Are you paying attention? N is the numbers of sample that you have. So, you know, you can have your sample in row or column. Whether your samples is in column or row, just subtract 1 from your sample. You understand? The total numbers of sample, the total numbers of elements or data that you have minus 1, that will give you the degree of freedom. Are you paying attention? So that is how I got the degree of freedom as what? 6 minus 1, that is 5. Okay, now to use this table, the first step is to identify locate 5 in the degree of freedom. And if you check, well, you're going to realize that this is 5. Okay, so D is the degree of freedom. If you check, you are going to see 5 here. And now you know that the level of significance is 5%. So 5% is also the same thing as what? 5 divided by 100. 5 divided by 100 is what? 0.05. You understand? So you can see 0.05 on the top here. This is 0.05. Let me erase it. This is 0.05. You can see. So you just have to trace it downward. You can see that when you trace it downward, you are going to realize that trace it downward to where we have 5 degree of freedom. You're going to realize that the value that is there is 11.07. Are you paying attention? The degree of freedom is 5. You have already located 5. Then the level of significance is 0.05. So you trace it downward to the value that is correspond to degree of freedom of 5, that is 11.07, as you can see. So the critical value is 11.07. do you understand? The critical value is 11.07. so that is how to use the chi-square table to determine your critical value, perhaps if you have not given an exam. Okay, so let's say your degree of freedom is 2. I'm just going to give you a test now. Let's say the degree of freedom is 2, and you are asked to determine the level of significance is 1%, and you're asked to determine the critical value. What will be your critical value? The critical value will be 9.21. Okay, how do I know? The first step is that just locate your degree of freedom. That is 2. You can see here, that is 2. Then, having identified your degree of freedom, 1% simply means 1 over 100, and 1 over 100 is what? 0.01. So this is 0.01. You can see. Now you just have to trace it downward to where you have the value that corresponds to the degree of freedom of 2. So when you trace it downward, you're going to realize that you're going to stop at 9.21. You understand? 9.21. that is the critical value for level of significance 1% and the degree of freedom of 2. Do you understand? Okay, so that will be all for this class. Please don't forget to like and share the video. Are you paying attention? And if you want to be part of this channel, subscribe, but please don't forget to like the video. Okay, see you in the next class.